Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1. We would like to present our project, which is the title is Basal Cell Carcinoma BCC using Recurrent Neural Networks RNN versus RNN plus SVM. Okay, before that, I will introduce our team member, who is Nur Ashikin binti Muhammad Isa, Fazlin binti Zulkifli, Nurul Shakira binti Samsul Bahari, Nur Ashafira binti Ishaq, and the last one, who is me, Wan Nurul Arisha binti Wan Asri. Okay, so let's start with introduction first. Okay, what is BCC? Basal cell carcinoma. BCC is the most common form of non-melanoma skin cancer, primarily caused by prolonged UV exposure, leading to abnormal and uncontrolled growth of basal cells in the epidermis. While BCC rarely metastasizes, it can cause significant local tissue damage if left untreated. Traditional diagnostic methods, including visual examination, dermoscopy, and histopathological analysis, can be subjective, time-consuming, and prone to human error. Recent advancements in AI, particularly deep learning models like recurrent neural networks (RNN) and hybrid RNN+SVM models, have significantly improved BCC detection classification by analyzing temporal imaging features with high accuracy. This study focused on leveraging AI-driven diagnostic tools to refine risk assessment, enhance classification models, and improve treatment consistency, ultimately optimizing patient care and clinical decision-making. Okay, so let's move on to the objective. So objective for this project is first to extract the features of different basal cell carcinoma BCC subtypes using image analysis technique. This involves processing BCC image through grayscale conversion, binarization, segmentation, and feature extraction to highlight key patterns in different subtypes. These abstract features are crucial for distinguishing between superficial, nodular, and infiltrative or morphiform BCC. Okay, second is to predict the classification in different BCC subtypes using recurrent neural networks (RNN) and hybrid RNN plus SVM models. The abstract features are fed into RNN and hybrid RNN plus SVM models to classify BCC subtype. RNN captures sequential dependency in image patterns while RNN plus SVM combines deep learning with traditional machine learning for potentially better classification performance. Okay, the last objective is to evaluate the prediction of classification and detection performance of the proposed and RNN plus SVM models in BCC diagnosis. The models are tested using accuracy, sensitivity, and specificity metrics to determine their effectiveness in correctly identifying BCC subtypes. A comparison between RNN and RNN plus SVM help assess which approach provides more reliable and accurate results for BCC diagnosis.
Hi, Assalamualaikum. My name is Nur Ashikin binti Muhammad Isa. So today I'm going to present and explain about our flowchart. So the flowchart outline image pre-processing, LSTM, model training, dataset, splitting, classification, evaluation, and accuracy display for the basal cell carcinoma detection. So first, our flowchart set the image for the parts, define the directory containing basal cell carcinoma BCC images. Next, identify the subfolder representing different type of BCC. We have type 1, type 2, and type 3. And then, set parameters such as image size, label, and counters. Next, for the loop through each subfolders, iterate through each BCC category folders. Next, load the image and resize them to a uniform dimension. And then identify the manage and any missing or unreadable images. and then save the processes images for the further analysis. Next, assign the labels to image based on the subfolder names, and then convert the image label into a format suitable for machine learning, and then construct a long short-term memory LSTM network for the classification, and then divide the dataset for model training and validation. Establish the structure of the LSTM model and then configure the parameters like optimizer, batch size, and the epoch. And then use training data to fit the LSTM model, and then test the trained model on the validation set, and then display the accuracy, which is output the model's performance.
Hi, Assalamualaikum. My name is Nashafira, and I will present about next is method. So we will cover morphology expression or also segmentation, adaptive learning, rates, and RNN plus RNN+SVM. So first, morphology operation. Morphology operation. These are techniques used to analyze and process image based on the shape and structure. So removing by removing noise, filling gaps, or highlighting specific features. Um, and then for the OXO segmentation, this method is for automatically finding the best threshold to separate an image into foreground and background. So like detecting tumor or in medical image or extracting tests from document. So in our project, we use for detect the cell, the basal cell for the medical image. And the next one is adaptive learning rates. Adaptive learning rates is control how to adjust themselves during the training, which help the models learn faster and more accurately. A gradient like Adam and RMS probe use this technique to improve the improvement. And the last one is RNN versus RNN plus SVN. So you can see this is our output for this what we call our project. Okay, this is output. So RNN and SVM models RNNs are great for processing sequential data like time series or text. But when you combine them to SVN, you get the best of both worlds. The RNN extracts feature and SVM provide robust calculation. This hybrid approach often leads to better accuracy and fewer of errors. So in this pictures, you can see this is in this figure. Uh, they have a low contrast or complete background. So it is making text difficult to extract. So also segmentation may not have effectively separated text from the background, and leading to an empty OCR result. If SVM was used, it may have misclassified the regions, causing text to be ignored. There and model may have struggled to recognize character due to image quality. So this is only example. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fazimi Zulkifli. Now I will explain about our source code. Okay, the classifier that we use is a hybrid approach combining LSTM, which is long short-term memory, which is from RNN network for feature extraction, and SVM, which is support vector machine for classification. Okay, so first we will load the BCC dataset. The image folder points to the root directory of BCC dataset, where each subfolder represents a distinct BCC type such as type 1, type 2, and type 3. Next, we will load all the subfolders from the main folder that each representing a different BCC type. Next, we will initialize the variable, which is image size that are set to 64 pixel. Next, number classes the total number of BCC folders. Next, images, an array to store all the process image. And lastly is missing images, a list to store the path of images that fail to load. Next, we will read and pre-processing the images. Next, labeling the images. Each image is assigned a label based on its subfolder, which correspond to a BCC type. For example, all image in folder type 1 are labeled 1, those in type 2 are labeled 2, and so on. Next, the label are converted into categorical format because neural networks require categorical data for classification tasks. Next, we will build the LSTM, which is RNN model. First, we will define the LSTM model, which include the model architecture, which is input layer, LSTM layer, fully connected layers, softmax layer, and classification layers. Next, we will split the data into training and testing sets. The data set is split into training and testing using a 70 to 30 split. This means 70% of the data is used for training and 30% is used for testing. Training set contains the images and labels used to train the model, while testing set used to evaluate the model's performance. For the training option, optimizer, which is Adam optimizer, is used for training, while epoch is the model is trained for 10 epoch, meaning the entire dataset is used 10 times for updating weight. Next, batch size. The model is updated after processing a mini batch of 32 images. After that, we will evaluate the RNN model. For the model training, the LSTM network is trained using the training data, which is x_train and y_train. After training, the model is tested on the testing dataset, which is x_test. Then the accuracy is computed by comparing the predicted labels y_pred_RNN with the true label y_test. Next, the output. The test accuracy is printed, showing how well the RNN perform on unseen data. Next, feature extraction and SVM training. First, we do feature extraction with LSTM and SVM classification. For feature extraction, the output from the LSTM layer is extracted using activations. These outputs are treated as deep features of the images. After that, we will train it using SVM. The feature from LSTM layer are fed into an SVM classifier with an ECOC approach. SVM is used to classify the images based on the deep features extracted by the LSTM. After that, the trained SVM model is used to predict the BCC type for the test set, which is LSTM features test. After that, we will evaluate the hybrid model RNN+SVM. For the RNN and SVM model is evaluated on the testing set to calculate its accuracy. The accuracy is reported, showing how well the hybrid model performs in classifying the BCC types. Then the output of RNN and SVM test accuracy is displayed as the final output. So, in conclusion, the current model demonstrates the use of LSTM for feature extraction and SVM for classification. The hybrid model has shown that promising accuracy in classifying BCC images.
Alright, so hi, Assalamualaikum. So my name is Nur Shakira bin Samsobari and I will present for the system. So as for the system, we already do the system coding. So we name it as BCC_GUI and we run by the script. So we load the image that we use in the data set, but we already divided the garbage one, so it will not included for the with the training one. So the input image and it will pop out 3 process image, which is segmented image, BCC mask, grayscale BCC. So that's all for our output that we already did for this RNN.
Alright, so we have come to the conclusion. So this study explored the classification of basal cell carcinoma BCC subtypes using recurrent neural network RNN and a hybrid RNN plus SVM model. Through image analysis technique, essential features of different BCC subtypes were extracted to improve detection accuracy. The classification models were trained and evaluated, demonstrating the effectiveness of RNN and RNN plus SVM in identifying superficial, nodular, and infiltrative or morphiform BCC. The results indicate that while RNN is effective in learning sequential patterns, the hybrid RNN plus SVM model enhanced classification accuracy by leveraging both deep learning and machine learning strengths. This research highlights the potential of hybrid models in medical image classification, contributing to improved BCC diagnosis and early detection. Future work can focus on optimizing model performance, incorporating more advanced feature extraction techniques, and expanding the dataset for better generalization.